tools. But this paper sort of does an analysis, gives a model of performance tools, and we thought that we learned something from the paper, and it's sort of the benefits of having people, academics, who often have more time to try to figure things out, not just worry about getting the next feature out the door. This was one of the things we thought would be a benefit of having researchers at this conference. So we've got copies of the papers. If you haven't picked them up, they're out on the table, and we hope this will be the start of something of a good tradition. So we encourage you guys, as you know people who are working with Smalltalk and who might write papers, and typically academics, but not necessarily academics, to let them know, tell them about this, and they can be planning for next year. Is a good thing.
Hi. My name is Alexandre Bergel. I'm French. I've been in Chile for 3 years already, and I've been lucky to find some very smart students at the university. So it's a piece of work that I've done with Bergel and Juan Pablo. So we've been doing research on code profiling for the last 2-3 years already. And so what does it mean to do profiling? Is you need to use code profiler whenever you want to have an idea of what's going on at the execution time. So here you have an example of a piece of code that we just do some parsing of some XML code. Like now, if you really want to know, what happens during the parsing, then we simply use code profiler. In that case, my example is based on Faro, so you will have like message telling. You just send the message on to the class, message telling is the block that you want to profile. And then we execute message telling, we execute the block, and then we output some more information about how it got executed. So in that case, we spend 100% of the time in the method parse, and there is a method called next tag that takes up to 15% of the execution, and then you have two methods handle on the size driver and XML tokenizer. But the profile could be fairly long. So we have, if we count all the different methods that were reported by message telling, we found that there is 21 methods on it. And if we do an exhaustive trace of the expression, using the unmade interpreter, we have found that there is 258 methods that belong to XML that are being used whenever you do parsing. So it means that message telling has reported about 8% of the methods. So you execute a piece of code, and then only 8% of the method are being reported by the code profiler. This is a big problem. So we were unsure whether this comes from the fact that we use the XML parser or not. So we took 8 applications, and for each of these applications, we run the unit test, and then we profile the execution of the unit test. And then here on this graph, we reported the amount of discovered methods that are been by the profiler. So we run for each of this application, we run twice the test. The first time using message telling that use the cut sampling, and the second time using our handmade interpreter that really report the amount of methods that have been executed. So in the average, there is 32% only of the methods that are reported by message telling. So this is a well-known problem. What do you do in that case? When you want to get more precision on what you're currently profiling. So what you simply put your expression you want to profile within a loop, right? So it's what you do here. So here we have a loop, 10 times, repeat the parsing. And then as output, then we have some more information. So the amount of time taken by the profiler is about roughly 10 times larger. And we have some more information. So the method next tag 15%. And then now there's 3 methods that have been reviewed. If we provide just one execution, then we have 2 methods only that are called by next tag. To profile 10 times the execution, then we have 3 methods. So we do the same thing with the different applications, and we run 10 times the unit test and profile them, and then we have seen that in the average, message actually report like 52% of the methods. So,
question: why didn't you reduce the rate in message shedding?
Because this is much more difficult to gain. I mean, like the profiling has been done like every millisecond. So you have one sampling at every millisecond. You cannot really reduce that. I mean.
Okay, it's weak, yeah.
Yeah, but even though like even in reducing like going below like 1 millisecond, then you introduce a lot of noise, and then you spend like a lot of time in profiling instead of executing. So yeah. But this is a good question. I mean, it's much easier like, to repeat the execution and profiling than reducing the frequency. So what are we talking about? I mean, there is nothing new so far. The fact that when we provide some multiple execution, then we have like, we just release more methods. And also the estimation are much more accurate. You know, like, if with very few iteration, then you must spend like a huge amount of method in one particular method, and then if you increase the amount of iteration, then this gets reduced to something more reasonable and more accurate. So now the research question that we had is like, how much trust can we put in a profile, in the output of a profiler? And profiling is a piece of code, and from the result, like, can I really trust it? And this is what we are really interested in. Like, so how precise is my sampling? How accurate is it? And different question is like, how long do I need to sample to get, let's say, 90% accuracy? So this is what we are talking about now. So going back to the example with the XML parsing, so this is the same piece of code as before, and then we will do an iteration on the amount of time I'm doing the parsing. So here I have an array that goes from 1 to, let's say, 200, and then with an interval of 10, and then we will do some measurement on the number of times the parsing is being done. And then at the end, this will produce a amount of measurement that we say for 1, 11, 21 iterations, I will have that amount of method that have been discovered. So we run that experiment, and then we got some data, and then we plot it down. So for that particular expression, it's when parsing, we obtain this curve. So horizontally, this is the amount of iteration. More iteration you're doing, and better accuracy you're getting with the profiler. By accuracy, I mean the amount of methods that are really involved that have been discovered, reported by message study. And vertically, you have the ratio. Obviously, the ratio is slowly tending to 1. You can't go above because the ratio of 1 means that message study has been smart enough to discover all the methods. So the first thing interesting that we have a nice curve here, and we repeated like the similar experiment with a bunch of applications, and we always found this nice curve. And this curve, follow the mathematical equations such as y equal a minus b raised to x. A and b are two fixed values, and a is a value that between 0 and 1, and usually around 7, 0.8, 0.9, and b is also a different value. So x is the amount of iterations, y the ratio I'm getting. And we find like a bit surprising that we always get this very nice curve. So this experiment has been done in Faro. We did the same thing in VisualWorks, where the JIT is much better, and the virtual machine is very fast. And we have like this very similar curve. Something got strange with OSK stream, but apparently the streaming is very particular kind of framework, and some weird behavior happens when you're trying to profile what happens when you do some streaming for some reason. But for Mondrian, for 2 application, then we have this nice curve. So now come to like the meta philosophical question is where this equation comes from. I mean, how come that we always have this equation? Like y equal a minus b raised to x. So, like we have an explanation of where this equation comes from, but yeah, this will raise a bit like the level of disproportion. So we got to talk about probability and so on. So we pick like an ideal model, which is in that case a binary tree. And this binary tree that has a depth of 3 will represent the core graph that we have discovered after an infinite amount of sampling. Now I will define a sampling. A sampling is a path that goes from the root, in this case the node A, to the bottom. And there is 8 different paths that I can take. And 8 because it's 2 raised to h plus 1 minus 1. So there, yeah, in the paper there is a bit of formulas about that. And yeah, okay, so in that case we consider sampling as the result of a graph traversal, a tree traversal that goes from the top to the root. And we need to introduce some events. The event that we are really interested in is that we call E1, En, and E1 means is the probability, this is the event of getting a new path after 1 sample. E2 is getting a new path after 2 samples. And En is the event of getting a new path after n samples. And we're interested in computing the probability of En. It's what we are driving for. Computing the probability of these events is slightly complex to do it straight away, so we need to introduce a new event, which is simpler to compute, which is this one, AI, which is the event of getting the path different from the previous shot. And once we have A1, then we can easily compute the probability of getting the probability of the event En, which is the probability of having A1 and A2 and until An. And since all the different events A1 to An are independent of each other, then when they are independent of each other, I mean for the same reason that if I have a coin, if I flip the coin, I can get, if I flip 10 times the coin, I can have like 10 times the head. But if I flip it again, I will have still one 0.5 chance to get the head, independently of what happens before. So that's why all the different events are independent. For the same reason here, like all the sampling are dependent from the previous one. So I mean that there is a statistician and probably a mathematician guy that apply these formulas here. That, the probability of getting A1 and N2 is equal to the probability of A1 times probability of A2. Okay, so coming back to our model, then we have the probability of AI, which is 7 divided by 8. There is 8 different paths, 8 different samples that I can get, and at each moment there is 7 out of 8 samples that will be different. That will be different from the previous one. The paper it should be like very well explained how. So it means that the probability of the event En is equal to 7 divided by 8 raised to n. But actually we're not very interested in computing the probability of En, but more not the probability of not En, which is getting an already sampled path. And at the end we obtain these formulas 1 divided by 2 and with some numbers raised to n. If we start to plot them, then we have this nice curve that we have seen before. So yeah, so this is really the equation we're interested in. So there is a lot of, so we have used an ideal model, which is a binary tree, but we won't go into detail, but using a tree with 3 branches, different balances, you have a similar formula. Okay, so we have found now that we get this shape. Now the real question is how to identify A and B. So if you give me an application, we'll be able to identify A and B. And so there is not really, an easy way to have it. So what we are doing currently is that we have the measurement. For given application, we run different profiles, and we get like a curve, an empirical curve on the left-hand side, and then we pick for an arbitrary B and A, we will have the curve on the right-hand side. So we have 2 curves. We put these 2 curves together, and then we start to do a scatter plot on them, and then we have some dots below. And these dots will, will form line more or less according to the bit that we select. And if I found the right B and the right A, then I will have a line of the dot below. And hopefully, like we would like to compare the B and the R square. R square, this is a number that's well known by the mathematician that says how how correlated your data is. And if you get something like close to 1, then it means that your data is really correlated. And by picking the right B, it means taking the maximum of the small curves of the crossing. For this particular application, like with the XML parsing, we found a B, which is equivalent to 4.7, which somehow seems to correspond to the average 8 of the method called stack. Yeah. Okay, so this is, that was for the theoretical part of the presentation. And I mean, this is also was the end of the presentation. So we have used like this model, this theoretical model, like to improve, to give some feedback about the profile or profiler is doing. So in the presentation I will give after the coffee break, I will show our profilers. This corresponds like to some data here at the top, where the profiler is telling the software engineers whether the profile is okay or not, or whether there is probability that it is inaccurate. And this is something like so far I haven't seen any profiler in the world that giving this piece of information. I mean, not only in Smarter, but like in Java world and C# and no profiler is doing that so far. Yeah, so I hope it was understandable. So with this work, we have been working on trying to get a better understanding of how code profiling works, and especially execution sampling based profiler, as most of the code profiler we're used to are working with. And we found that there is a relationship between the number of iterations and profile accuracy. This is what we are really interested in, because then we can put this model with Kyle, which is the name of our profiler that I will show a bit later. Yeah, so thank you very much. So that's all today.
Is Kai for Pharaoh as well?
Yeah, so there is a version in Caro, there is a version in Pharaoh, and there is a version in VisualWorks. Currently, we are pushing very hard the VisualWorks version. Something that we'll talk about a bit later.
Anybody have any questions?
Question on, you talked about the percentage of discovered methods in the beginning. Was there any impact on the accuracy of where time was spent, even though it wasn't picking up all the methods? For the accuracy of the profiling, was it still picking up where it was spending most of its time, or can you comment on the accuracy of that?
Yeah. So, I mean, like, making sure how you get an accurate profile is very tough. So, and apparently, like when you have like few methods that have been discovered, then you have apparently you have some wrong estimation of the time you spent in the method. Like at the end of the execution, you have 100%. And if you have less methods that have been reported, then the sum of all the methods has to be 100%.
Yeah.
And then you may spend like, let's say 50% in one method with with a very short execution time. If you increase the execution time, then you may say, oh, we didn't spend 50%, but let's say 30%. And the remaining 20% are in this method. And for the usage of the profiler that we are currently intended to, such as real-time applications, and
There are two presentations.
those 20% that you may miss are really important.
Two presentations.
So, but this is a very good point. I mean, currently we're currently working on emphasizing what does it really mean to have an accurate profile. This is not really an easy question, but we are hoping to have something really like a great profile.
Thank you.
The more profiling you do, the more accurate the picture you get.
So
you created a graph. It looks like that.
Actually, Alexandre is going to give a presentation on Pharaoh, right? Are you going to do that?
Yeah, no, I mean, I thought about doing that now.
This is the reason I came to this conference.
Yeah, I have a few slides about Pharaoh and
Ask questions. You want to ask questions.
is that okay that I show a bit about Pharaoh?
So
I mean, some people have
the way we have half an hour to the break time. And then the other people will be having break at that time. And so the suggestion was that he could, because you were originally planning to do something yesterday, and you decided to not do it yesterday. And so he'll tell us something about Pharaoh. Is that fine? Okay, yeah.
Right.
People like it.
Yeah, I mean, Pharaoh is something which is getting bigger and it's getting really a lot of traction, and I think there's some very good stuff in that. So I've been using like Pharaoh since the very beginning, before I was a quick user, and even before I was a beginner, was
I believe it's that.
user. And
That one's an English.
until recently, I've been using essentially Pharaoh.
Much clearer when you read it.
So I think it's good that I can talk a bit about that. So I drew literally the slides that Marcus Benker did and presented at issue. I removed a lot of slides, but I think that the idea is there. So Pharaoh is a small dialect that has been there for 3 years already, and is moving, it's really moving fast. So the ultimate goal of Pharaoh, really the ultimate goal is to create an ecosystem where anyone can create in a very easy way business and innovation. This is really the ultimate goal. To have a very small, to have a small product that anyone can do this thing. So there is another like of success stories, and just a few of them have been reported, but there are really pretty many of them. Like, and there is Seaside that has been first made in Squeak and then in Pharaoh. There is NetStyle. There is a number of companies in Belgium. There are all the peers. Content management system, there is Dr. Geo with ILA. There is the CMS box that is based on Seaside. There is the Beta 9.
What's YesPlan be? What's YesPlan.be? I know what NetStyle.ch is, but what's the?
YesPlan, this is the company that has been set by Johan Brichel.
So it's a event planning software.
Event planning software.
Yeah, exactly.
It's a desktop style app for event planning that is hosted on a web browser.
Right.
So it uses Seaside.
I mean, this list is not complete. I mean, there is also a number of young people full of energy in Argentina who may get some startup, using Seaside. So, yeah, it's growing. So, to be able to even to future, this is really like what drives the whole community behind Pharaoh. So I know a lot of things really has been done so far. So the 1.3 has been released with a lot of improvements. I mean, like I think we reached the threshold like 5,000 entry has been closed on the Google Seaside website. So more than 5,000 bug entries have been addressed. So which is really cool. So it's moving fast. So currently we are at 1.4 release. There is Jenkins for everything, really everything. A lot of different projects, it's running every day, like the whole test of Pharaohs. It's also building, some ready-to-use image. There is all the VMs also are automatically generated using Jenkins, which is something not trivial and easy to get. So yes, so there is a lot of people working on that, and these don't complete, but we have like people from London, with Gary Chambers working on the better widgets, Adam Plantek, and Ben. There are also Benjamin started to work as a small internship, to design a new browser, and not this, which is really appealing. There is the key manager, there is a number of serializer with Martinez Peck and the other guys the other Argentinian guys. There is a source code model, which is the result of the PhD of Veronica Pigas Gomez. After there is the work done by Marcus Benker on the new compiler. There is a new zoomable interface, Bootstrap, like a distribution infrastructure. There is the network, the remote Smalltalk as well. There is also the Git integration by Dell. I mean, there is a number of things.
Can I ask a question about the remote Smalltalk? Nuri Burakardi, he was working on remote Smalltalk 5 years ago.
Yep.
And that was his thing, and then Pharaoh came along. He's working on, is that part of Ocean, his rewrite, or is this something else? Has he started working on remote Smalltalk again, or is this the Ocean project to rewrite the networking?
Okay, so I can't really tell about the status of Ocean. I don't know. I mean, last time I've seen them, they were working on that. Currently, they've been like quiet on the mailing list. I don't know what really happens. But yeah, I mean, you know.
So maybe that's part of Ocean. Okay.
Probably. I would expect remote Smalltalk to use Ocean at some point, but that's what we see. And yeah, the roadmap is quite simple. It's building the infrastructure for the next generation. So yeah, maybe we won't spend too much time on each of the slides. Now we go in with some details within each of the beta that I said previously. Now being able to create all different versions, this is what the code model infrastructure is supposed to do. Like, such as answering the question is, what are the standards of these methods in the version that we had 2 or 3 months ago? This is one important question that currently we can't really solve currently. So what is the difference between the standards in the past and the one we have from now? Actually, this is something that is quite important, you know, in my head sometimes. So Ring, this is the meta model to represent the source code. This is the result of the work of Veronica. So this is the source code meta model. The API is compatible with contact objects. This is key to have a nice integration. Then you can add like layers on top of it, and yeah. So then there is Athene, which is a new canvas. This is vector graphics. So this is going to be a layer, and this is the layer that we have between the high, level tools that I have, and then the bit and drawing the pixels. The idea is to be able to have all drawing done either in Caro, in OpenGL, or whatever the next graphic framework we want to have. So there is OpenGL that uses native Boost, and it works well on Windows, and currently doing some work on OS X. So there is Upal, which is the work of Markus Zenker. This is a new compiler. So for a number of reasons, like the current compiler is quite fixed, static, rigid. You can't really do things, especially the thing that researchers want to do usually. And yeah, so Upal is going to be like a code compiler. It's going to be added in 1.4 very soon. Throw away the whole compiler. This is one goal. Fuel is really cool. This is a very fast serialization framework. I mean, you can get binary of your object very, very quickly. And yeah, it is not based on the mesh segment, even though mesh segment was slower. It's slower than Fuel, and even mesh segment has been removed from Squeak. And Fuel is much more flexible and easy to understand. Also, there is documentation about it, which is quite cool. Yeah, and so there is something that has been done over the last few months is to have a scripting syntax, which is called Coral, and writing using Emacs plan.st file that you can just give to Faro, a headless Faro, and then you just do the execution. And it works well. I mean, I tried 2 days ago. It really works well. So here, a small example. I mean, here we have this class console that we just do the print string on the terminal, and we have some syntax to create classes, subclasses, methods. That doesn't use the question mark, this character. Do you understand? How does this character?
Exclamation.
Exclamation. And yeah, so this is getting distribution. This is something that there's quite a bit of work being done on that. It's moving, it's really moving. But the idea is to have a distribution that one day you have to go to Mars just with a DVD and no internet connection. You should be able to install the version, let's say 2.5, 2 years ago of Mongolia. That could be one example. And certification of packages, like having the lint rule, the test, everything integrated with Jenkins. So this is something that is really happening. Native Boost, actually, I'm not expert in that area, but many people tell us it's really cool. These native boosts you can integrate, you can use some external library, but then you use some kind of assembly generation on the fly. And yes, this is kind of better than FF5 because you generate things that you might need for some reason. But yeah, a lot of people got driven to that by that. And the VM also, the VM writing test for the VM, this is something that this is on the roadmap. Like making the virtual machine work like something that is understandable for common humans. I mean, this is a very, very difficult topic, and personally I'm not able to understand the blogs of Miranda, and I'm not the only one, I know that. So having everything like in well packaged, well distributed, this really goes into getting a better understanding of how the things work.
Any plans for a JIT?
Yeah, I mean there is a JIT in the VM, so the Elliot has worked on that for quite some time, and this is really magic. I mean, one day after the other one, we got a new VM. You install a VM, it's like changing the computer. And it really works well. It really works well. I mean, now, personally, I'm using the NGT version because if I want to modify the method lookup within the VM for my experiment, everybody is using the JIT version, and because it's fast, not as fast as the Visual Works VM, but we are getting there. Yeah. Yeah, so there is some work on the browser. And there is the mini image. This is Pavel. He has been working on that for quite some time already, and then he has stripped down like an image.
So I thought that Pharaoh used Omnibrowser, and Omnibrowser doesn't do that.
Yeah.
Just the last, you talked about throwing some string browser in there, some string holder, but that's the old browser. That's
Yeah, okay. So this is the old browser, but I mean, Omnibrowser is a proof framework, but then you're really stuck into this, this pan that you have to go from left to the right. So Omnibrowser is really cool, but then you cannot do something else than just copying the normal old browser. It's just having like a different button here that will switch the view is getting complex.
So this is so that people can make wild and crazy browsers. So they're trying to have a new framework so people can make very different browsers.
Yeah. So Nautilus is a new browser that Benjamin has been working on for quite some time, and it really works well. So this is the standard browser that now people are using. Which really works well.
Instead of the browser.
Yeah, I mean, you can define groups, you can define, you have different views, such as the hierarchies of the package, something that you have in Visual Works for years, but took some time to get that in power.
But I think Omnibrowser is still usable in Pharaoh.
Yeah, no, it is.
This is the primary.
Yeah, I mean, you can choose what but since then it's very close to Stefan, and therefore no, we go direct for Nautilus. In my opinion, it's a good decision, I think. So there is the mini image, then there's been some experiments to strip down like the Pharaoh image. Like Pharaoh can be as big as, I think like 400K, and like 4.2 megabytes for CSI image, which is quite reasonable at some point. So the future is bright. Anti-boost is going to be a big thing. So like there's been some thinking about getting the Google anti-client is to have like Pharaoh running within a web browser. There is actually full bootstrap. It means that having a set of declaration and specification how to create an image out of nothing. I mean, the small doc image, the one to use in Pharaoh has been there for quite some time already. And so about the security. And yeah, so Inoya is highly supporting Pharaoh. So Inoya which is the French research center, national research center in computer science, and Pharaoh Inoya is really putting like some effort on getting a consortium. It means that community of this company that are willing to pay to get a better firewall. And this consortium will answer the question like how to maintain firewalls and how to structure the community, how to make sure that decisions and important bugs are taken, are fixed, addressed. So anyone can participate in this consortium. So it depends, you have to pay for a fee. And the idea is to get enough money that you can have 1 engineer. Currently there is 1 engineer. There is Esteban Lorenzano, and from Argentina, he's now in Lille for 1 year. There is also Igor from Russia that is in Lille, and he has a contract for 2 years. There is books. There is the French version, Spanish, the English version, and the Japanese and German on the way. So like volume 2 of law, for example, is coming. It's coming. There is already a number of chapters that are available. There's also like a book like Firewall from Enterprise. So this one is slowly coming, but people are willing to have that. And yeah. So something like is interesting is that one big difference that there is with Firewall and other Smalltalk is that with all different features of Firewall, among all different features of Firewall, you won't see like backward compatibility. So it's very frequent that you come in the morning at work and you see that you have like 12 tests that are just broken. What happens? And this happened like for the Moose, and we have like the new version of the Union, the different class collection that has changed, and then put many tests just got red because of that.
The book, the Pharaoh by Example 2, Deep into Pharaoh. What do you mean by deep? Is that going to explain some things in the virtual machine, or?
Yeah, very internal of Pharaoh. So there is a number of chapters already available. For the chapter I wrote, there is one about Mondrian, there is one about Monticello, one about the exceptions, and there is another one about chapters.
Great.
So as Pharaoh matures, is the hope to get away from what you had just mentioned, where you come in the morning and your Pharaoh code doesn't work anymore?
Everybody, it's easy to understand this is a big problem. So Pharaoh emerged from Squeak. Squeak, there are some very good things inside, but it hasn't been done in a very modular way and easy way to understand. So we really spend a hard time understanding how it works and cleaning. This cleaning process has been there for since the very beginning of Pharaoh. So cleaning, removing all code that nobody understands, nobody maintains. So by having a very small core on which you can load packages in a very easy way, this will be the answer of making sure that your application is not broken. Yeah, so that's all. That's what I want to say. So thank you very much. Yeah.
Great time. Thank you all for coming.
So what's the fee?
The fee.
So after this is the second talk for Smalltalk Directions.
No, there is only one, because the authors couldn't make it.
Oh, so Smalltalk Directions is now over.
Yes.
Okay then. Good to know.
Yeah, so we are pretty unhappy. We're pretty unhappy.
There we go. Yeah, so for research we have, it's very frequent that we develop some research prototype. And, not only to support our claims or assumption in research, but also to make us confident that we are truly doing something useful. And so we have built many profilers over the last 2 years. And but there is only 2 of them that we are turning into products that you can really download as soon as you are doing Firewall and VisualWorks, and they are free. So I'm going to present 2 profilers. The first one, which is Kai, and the second one, which is Apao. I will talk a bit about that later. So the first one, Kai. Kai, this is a code execution profiler. And I mean, there are plenty of profilers around, but most of the profilers that you can see, not only in Smalltalk, but also in Java and C#,